Hello, everybody. Today we are doing a note on verifying geometric properties. So verifying geometric properties means that we are going to be given a statement that we are going to verify to be true. Okay, so oftentimes, drawing a diagram helps us fully understand what the question is asking, but we need to use our knowledge now of analytic geometry to verify and show a reader that something is true using our knowledge of analytic geometry. So things like how to find slope, the equation of a line, the distance between two coordinates, midpoints, medians, perpendicular bisectors, etc. So what's important here is the burden of proof. So what I mean by burden of proof is that you have enough information, you show enough information to actually prove or verify what is being asked. Okay, the reason why this is called verifying and not proving is because we're just showing that a specific numeric example is true. Proofs occur later on in high school mathematics and definitely in university level mathematics when you're proving that a relationship is true no matter what the numbers are. But in this section, we actually call it verifying because we're just verifying that a specific example is true. Okay, so our final sentence is going to be very important. We want to say and explain how we came to our decision that the statement is true, not just saying, therefore, the slopes are, or therefore the lines are parallel. We want to say, since the slopes are equal, the lines are parallel, things like that. So here's just some examples of things that will happen. To prove two lines are parallel, we need to show that they have the same slope. To prove that one line segment is half of another, we find the lengths of both and compare them to each other. To prove a triangle is isosceles, we would find the lengths of all three sides and show that two are the same length. To prove that a quadrilateral, that should not say is an isosceles, that should say is a parallelogram, we show that opposite side lengths are equal and that they're parallel. To prove a point lies on a line, we would show that that point, when we put it into the equation, satisfies that equation. That proves that the point is on the line. So you get the idea. So what is going to be important here again is your burden of proof and understanding how to give enough information. So I will do 3 examples that will show this, and then I will also refer to 2 extra examples that you can read in your textbook. So the first thing you should do with all of these, as I keep saying, is draw them, okay? Use your graph paper and draw it out. That will allow you to find any numerical mistakes as you go, okay? So in a triangle with these coordinates, I graph them out. D is the midpoint of side AC, and E is the midpoint of side BC. So verify that the line segment DE is parallel to side AB. So to find this line segment DE, first we need to find D and E. So it says that D is the midpoint of AC. So we can find that. So we add our x values together, and divide by 2. We add our y values together and divide by 2. Okay, so the point D then is 3, 2. And so we can graph that. 1, 2, 3, 1, 2. Oh, I made a mistake. What did I do? I was using B as these x values. That was my bad. It should be 1 plus 7 and 3 plus 5. So you see what I mean, guys? I did that on purpose. You might not believe me. Because I made a mistake. I was just using the wrong thing, but now because I did it visually, I saw that I made a mistake. So 1, 2, 3, 4. 1, 2, 3, 4. That looks right. There is our midpoint D. Okay, so now we can find E, which we were told is the midpoint of BC. So let's see if I can do this without error now. So BC, it's 7 plus 5 over 2. 7 plus 5 is 12, divided by 2 is 6. 1 plus 5 is 6, divided by 2 is 3. So if you can do that in your head, you don't have to show me that much information anymore. As long as you just show me that you're finding the midpoint of BC. Okay, so now it's saying that the line segment DE, okay, so we need to draw that line segment. It's that it's parallel to side AB. Well, two lines are parallel if their slopes are the same. So we need to find the slope of DE and the slope of AB and show they are the same. So just make sure that, your slope looks like the M with the little rounded humps there. So the slope of DE, so it's y2 minus y1, so 3 minus 4 over x2 minus 1, 6 minus 4, so you get negative a half. Okay, I will do the same thing for the slope of AB, and I'm hoping that it's also negative a half. So 1 minus 3 divided by 5 minus 1 gives me negative 2 over 4, which is negative a half. Yay! Okay, so now here's the important part, which is the sentence. So we think, okay, yes, they are parallel, but how did we know that? We know they're parallel because their slopes are equal. So we need to say how we came to our verification. So now this is where notation becomes really helpful because we don't actually have to say since the slopes are equal. It's better to use this notation. So since the slope of DE is equal to the slope of AB, comma, DE is parallel to AB. Now you can write out is parallel to, or you can put these two lines if you want to learn some new notation. So DE is parallel to AB, or you can actually write is parallel to. Okay, that I will let you choose for now, but it is nice and looks kind of like important and cool when you know the short form because you don't have to write as much and you look really smart and important. Okay, now we want to verify that the line segment DE is half the length of side AB. So we need to find the length of DE, the length of AB, and show that one is half of the other. So first we will find the length of DE. So that is our distance formula. So again, remember that's Pythagorean theorem. So DE, we subtract our x values, 6 minus 4, all squared, and then subtract our y values, 3 minus 4, all squared. Okay, make sure those are in brackets when you put them in your calculator. So this gives you 2 squared, which is 4, and then negative 1 squared, which is plus 1. So you get the square root of 5. Okay, so now let's find the length of AB. Notice I'm using my notation here. Okay, so again, subtract the x values, squared, subtract the y values, squared. So you get 4 squared, which is 16, and negative 2 squared, which is 4, and you get the square root of 20. Now, this is a bit confusing for students because on the surface, it looks like AB is actually 4 times DE because 20 is 4 times 5. But square roots don't work like that, okay? Square roots don't multiply by what's under the square root. So there's 2 different ways that you can look at this. Either you can turn this into a decimal and this into a decimal and compare the 2 decimals, and you will see that DE is half of AB. But an advanced way of doing this is to simplify square root of 20. Now the square root of 20 can be rewritten as the square root of 4 times 5. And then that can be rewritten as the square root of 4 times the square root of 5. I'm choosing 4 here because 4 is a perfect square. So I know that it can be perfectly square rooted to 2. So the square root of 4 is just 2. And then you leave the square root of 5 because you can't simplify that. So now take a look at this. This is 2 root 5, and this is just root 5. That is very clear to the reader that AB is double the length of DE. Okay, so now we can say that AB, the length of AB is equal to 2 the length of DE. We should say since in front of that. So since AB is twice DE, or actually we don't need to say since. We can just kind of show that, or we can say that DE is equal to 1/2 AB. Okay, because it's clear in their lengths. All right, so there we have a triangle example. Now we're going to move on to a quadrilateral. So a quadrilateral is just anything that has 4 sides. It can be a weird looking shape. It doesn't have to be a parallelogram or a rectangle. That scared me. It can be any, we just had a power surge. I hope this is still recording. I'm just gonna check. Yep, there I am. Okay. Anyways, so there we go. So we want to show that this quadrilateral, EFGH, formed by joining the midpoints of adjacent sides, is a parallelogram. So we need to find E, F, G, and H, which are the midpoints, before we can actually show that that is a parallelogram. So this is quite a bit of work. Okay, so what we need is let's think of a plan first. So we need, step 1, we need all midpoints, because they're not given to us. So we have to actually find them. Then step 2 is going to be show that opposite sides are parallel. Okay, so in other words, like the slope of EF is equal to the slope of HG. And the slope of EH is equal to the slope of FG. Okay, we're going to have to do that. Then we have to show that opposite sides have equal length. If we can do that, then we will prove that it is a parallelogram, because parallelograms have parallel opposite sides and opposite sides of equal length. So step 1 is finding all of these midpoints. So I'm just going to assume, guys, that you know how to find midpoints. Okay, so I'm going to label them just to save time for the video. So our first midpoint here, I called this one G, and it is 4, 1. Okay, it is the midpoint between D and C. And the midpoint of AD I called H, and it is negative 1.5, positive 3.5. Okay, so I called that one H. Now, I am going to say that it is okay to use decimals if you want, only because they're at 0.5s, okay? 0.5s are okay because those are exact decimals, but something like a third wouldn't be, because a third just estimates to 0.33. It's not perfect. So this E is -1, -1.5. So if you're not sure when it's okay to use fractions and when it's okay to use decimals, then always just use decimals. Okay, I didn't do this one perfectly because I didn't draw the line perfectly. But this midpoint F is 4.5 and -4. Okay, so again, if you're not sure if decimals are okay, then use fractions when in doubt. But I will say the general rule is if it's a 0.5 or a 0.25, I'm okay with you using a decimal. Otherwise, you should use a fraction. But never use a combination of decimals and fractions. You got to use all one or all the other. Okay, so we're looking at this shape, the one where you join adjacent sides. So we got to show that this blue shape is in fact a quadrilateral. So we have the midpoints, step 1, check. And in your work, you can actually show how you find them, or you can just label them. If you do it in your head, it's up to you. But midpoints, I'm going to assume you guys are good on midpoints. Okay. Okay. So now we have to find all the slopes. Okay. All 4 slopes. So let's start with the slope of EH. Okay. So that's here, E to H. Okay. So we take our y values, negative 1.5 minus 3.5, and we divide our negative 1. It's minus negative 1.5, so plus 1.5. And you get 5 divided by negative 0.5, which is negative 10. Okay, so now I'm going to find the slope of GH and hope that it's also negative 10 so that they are parallel. So again, we take our negative 4 minus 1 divided by 4.5 minus 4, and you get negative 5 over 0.5, which is also negative 10. So yay, that's good so far. So now let's do HG and EF. So the slope of EF, so we do our y values first, negative 4 plus 1.5 divided by 4.5 plus 1, which gives us, okay, now this is where decimals get weird, negative 2.5 over 5.5. Okay, never leave a fraction as a decimal over a decimal. Put it into your calculator and you should get negative 5 over 11. Okay, if you don't get that, a way of doing this by hand is just multiplying the top and the bottom both by 2 so they no longer have decimals anymore. And if you do the same thing to the top as you do to the bottom, then it's maintained its correctness. Okay, so that's the way to do that. So the slope of HG, I'm going to assume you know how to do that. You also get to minus 5 over 11. Okay, so that's step 1. We've shown that these two slopes are equal and that these two slopes are equal. So now we have to show that the side lengths are all the same. So again, because there's a lot of calculations, I'm going to speed up the process for the sake of the video and assume that you know how to apply the distance formula. If you are not confident on this, so sorry, this is EH. Please see me, okay? Don't let that go. Please actually see me so we can talk about it. All right. If you go and find the distance formula of EH, you get the square root of 25.25. Now, this isn't a very pretty number. Really, you could turn this into a decimal if you want. But the only reason we're really using these right now is to show that the distances are the same. So if I get 25.25 under the square root for FG, then I'm good. And guess what? That does happen. So those two are the same. So now let's check EF and HG. So again, you'll actually have to do more work to find these distance formulas. You can't go right to the end. For some reason, excuse me, I didn't actually find that. Okay, so you get the square root of 36.5. And when you find HG, you also get the square root of 36.5. Okay, so now that you've done all that mathematical work, and I know it's a lot of calculations, what's important is your final sentence. So we will say, since the slope of EH equals the slope of FG, and the slope of EF equals the slope of HG, comma, opposite sides are parallel. And then we can say, since EH, the length of EH equals the length of FG, and EF, the length of EF equals the length of HG, opposite sides have equal length. Therefore, EFGH is a parallelogram. Okay, there we go. Okay, last example, and then like I said, I will refer to 2 other examples for you to read in your textbook. And if you want me to go through them, I will go through them with you, or perhaps we'll do them in class tomorrow. So we have this quadrilateral, and we want to verify that the diagonals of this quadrilateral bisect each other at right angles. So diagonals is when you take a point and you connect it with the opposite point. So this point connected with this point. So we want to show that the diagonals bisect each other. So let's call that point A. Okay. And that these two do so at right angles. So basically, we need to show that PR is parallel to QS, so that they have slopes that are negative reciprocals. Okay. And we need to show that. Now, how can we prove that the diagonals bisect each other? Well, if the midpoint of PR is the same as the midpoint of QS, then that means, so in other words, they're the same point. So the midpoint is the same point, then that means they bisect each other. So all we have to do is show that their midpoints are the same. So that's something good to know for other questions that will come up in your textbook. Okay, so the midpoint of PR, I can do this pretty quickly, is 3, 1, and the midpoint of QS is 3, 1. Okay, so since the midpoints are the same, they bisect each other. Then we can find the slope of P. So let's do QS first. Okay, so 1 minus 1 divided by 6 minus 0 is 0 divided by 6, which is 0. That makes sense because QS is a horizontal line. Now, what happens with the slope of PR? This confuses some students. So you get your negative 1 minus 3, and then 3 over 3 minus 3. So negative 4 over 0, which means it's undefined. Okay, if you do that in your calculator, you'll get an error. So how does this show that they are perpendicular? Well, a slope of 0 means that, ding, 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 let me get a red here, nice pink, means that you have a horizontal line, and an undefined slope means that you have a vertical line. And we know that horizontal and vertical lines have to be perpendicular. Okay, so we can since the midpoint of PR equals the midpoint of QS, and QS is parallel to PR, the diagonals, okay, then you can just finish the sentence. The diagonals of PQRS bisect each other at right angles. Okay, so after this, you can go into your textbook, have it written, check page 147 and 148. They have some more stuff with circles and proving points are on lines, but hopefully this is enough for you to see the type of work you need to do and the burden of proof that's expected on you to do well. Okay, so thanks for watching, guys. Hope you learned lots.